This video is a bunch of questions from your practice booklet at the end on similar triangles week 9. And I'm going to go through and do these questions with you. So if you're having some troubles, you'll hopefully be able to clear them up before your assignment. Question 1 says, write a similarity statement and write the ratios of the corresponding sides. First of all, you should look at this diagram and recognize you've got an equal angle, equal angle, equal angle, equal angle. Therefore, you have 3 sets of equal angles. If that's the case, then these triangles have the same shape. If they have the same shape, they are similar. To write a similarity statement, you put a triangle symbol in front and list 3 vertices of your triangle. Order doesn't matter. For example, say you did PQR for the first triangle. The order of the second triangle is what matters. It must match. So I put P first, therefore X has to come first. I put Q second, therefore Y has to come second. Corresponding angle, and Z must be third because it corresponds with R. That's really important, that the P and the X, the Q and the Y, the R and the Z all line up. Corresponding, write the ratios, it says. The ratios for corresponding sides. Again, the order doesn't matter, but it does kind of matter for the second half. Say I did PQ is corresponding to XY. So the second one for my ratio would be from the left triangle. Say I did QR, that's proportional to YZ. And I could do PR is proportional to XZ. And that is a proportionality statement, a bunch of ratios of corresponding sides. You can use that now to solve the missing ones. So let's say I'm going to solve for X first. I know that PQ is 4, XZ is 12. In the second half, I must have the left triangle on the top. 3 corresponds to X. Now you should be able to recognize here that the triangle on the right, 4 to 12, is 3 times larger. Therefore, even if you don't do the math by a proportion method, 12 times 3 is 36, divided by 4, you should see that the length for X should be 9, which is 3 times larger than QR of 3. To solve for Z, again, you're going to want to use a given equal or a given ratio that has both numbers in the question. 4 to 12 would be equal to the ratio 4 to 12, 5 to Z. Cross multiply, 12 times 5 is 60, divided by 4, so Z would equal 3 times larger than 5, 15. And they're all millimeters. So my answer should include a unit to be consistent. Okay, question 1's done. Number 2. I'm told that triangle PQR is similar to triangle STB. Therefore, I know that angle P is similar to angle S. I'm told that angle Q is equal to angle T and angle R is equal to angle V. Now these triangles are very obviously similar in the way they're lined up side by side, but I have to actually know that to be able to use the ratio method. Okay, just wing it, I have to know it. So a similarity statement could be then triangle PQR. Similarity just means you put your triangle symbol and similarity in the middle, and then you carry on. PQR is similar to triangle STV, if it was neat. Triangle STV. And that's a similarity statement. The order matters in that they match. It could equally have been, for example, triangle RQP. As long as that's oriented properly, it would have to have been triangle VTS. And that would work. Corresponding sides again. So for example, QP is proportional to TS, and PR is proportional to SV, and RQ is proportional to VT. Plugging in the numbers, these are obviously proportional. So QP is 22 over 16. The second half, I want to solve for QR and for SV. So SV we don't know. SV is unknown, but PR is 14. So to solve for that, we're going to cross multiply and divide. SV is equal to 12.4. No, it's not. SV is equal to 10.18, which is 10.2 when you round the nearest tenths, and that's in centimeters. To solve for the other missing side, which is QR rather, 22 over 16 is going to equal QR from the top triangle letters are unknown, divided by 9. So 9 by 22 divided by 16. QR would equal 12.4 centimeters. So you're applying old skills of proportions to a new concept of similar triangles. And similar triangles are the basis upon which trigonometry is calculated. So it's important that you get this straight to be able to move on to trig. Number 3 says, show your triangles are similar. Basically, with your knowledge, write that they're similar, tell me how, write the ratios, and then solve for the lengths. So I look at this triangle, I see a 63 and a 63, a 44 and a 44. If those two angles are equal, two sets of angles that are equal, the third angle must be equal by law, which I can show with a check mark. So a similarity statement would have to be in proper order. So here we go. Triangle, let's just say we did NPM. From the 63 to the 44 to the check mark is similar to triangle DEF. From the 63 to the 44 to the check mark. Now, corresponding sides, once you have your similarity statement, you can do your corresponding sides by using it only. For example, you could say NP is going to be proportional to DE. You could say PM, which is the other side, is proportional to EF by doing this. For example, these two, those two. You could do first and last, which would help you to get the third one. NM is proportional to DF. What do we know? We know that the side from the 63 to the check mark, which is NM, is 5.7, and DF is 3.8. And those sides are corresponding. And I want to use that information to solve for the missing lengths. Let's first of all solve for, pick a side. On the top I have the big triangle, so I'm going to put, let's do PM, 6.2, and that side corresponds from the check mark to the 44, that corresponds to EF. So if you cross multiply and solve, 6.2 by 3.8 divided by 5.7, EF is going to have to equal close to, but a little bigger than, to be 4.1 centimeters. Close to 3.8, but a little bit bigger. And to solve for the last unknown side, which is DE, you would have to use the corresponding side, which is between 44 and 63, 7.1 on the bigger triangle. And you would use 5.7 again over 3.8. 7.1 times 3.8 divided by 5.7. DE is going to equal a bigger number, 4.7 centimeters. So you might have chosen in this one to follow my earlier advice and maybe rewrite the smaller triangle by drawing it beside the bigger triangle with the same orientation. The 63 down here, the 44 up here, and the check mark up there. And you might have, this is your D, this is your E. It's not a bad idea to do that. Helps you then if you're at all spatially challenged, so to speak. That does tend to help to draw them side by side with the same angles. Okay, let's do question number 4. This is a fun one. BD, 14.0 centimeters. DA, 2.8 centimeters. AC is 7.4 centimeters. And we're told that angle CAB is equal to angle BDE. Let's talk that through. So angle CAB, which is here in the upper right-hand corner, this angle in here, that's equal to angle BDE, that one there. Now we have one set of equal angles inside this two-triangle pair. You should also recognize that angle B is the same angle if you were to draw the small triangle by the bigger triangle. This is triangle BDE. And the bigger triangle, of course, is the same shape, but larger. The bigger triangle is triangle BCA. Angle B is angle B in both triangles. Therefore, it's a given. We were told the top angles are equal. That's all we need to prove that the triangles are similar, because we just have to show that two angles are equal. The third angle is equal by law, because once two angles equal, they have to add to 180 with a third. Therefore, they're equal. Now that they're similar, I can now use the information, hopefully to solve for the missing side. AC is 7.4. DE is the unknown, question mark. BD is given 14 centimeters. And AB is given, but not directly, as the sum of the two lengths you were starting with. So 14 plus 2.8 would be 16.8. Now that you can see the way it's set up, you can make a ratio. BD is 14. That's corresponding and proportional to 16.8. And the other half, if you proportion, DEs are unknown, and AC is given as 7.4. We're going to solve by cross multiplying 14.0 by 7.4 and dividing by 16.8. So you get 6.16666, but you're told in the question to round to one decimal place, so you would end up with a final answer of 6.2 centimeters to get the value of D to E. Okay. Question 5. You have given NO is 13.4. You're given PQ is 5.1. You were told that the ratio of sides MO to OQ is 8 to 5. MO to OQ is in a ratio of 8 to 5. Interesting. You're not given direct values, but you're asked to still solve for the unknown. Find MN and PQ. That should say PO. We already know PQ. So you want to find this, and you want to find this. Part B then says find the total area. Well, one thing at a time here. We don't know directly the values of MO and OQ, but we do know the ratio. So instead of writing the actual values, we're going to write the ratio. We are going to recognize also that that angle and that angle is equal. Therefore, we have similar triangles. Triangle, for example, NOM. So from the right angle to the dot to the unmarked angle is going to be similar to, not equal to, but similar to the triangle from the right angle P to the dot O to the unmarked Q. So we know then that NO is proportional to PO. We know that NO is 13.4. PO is unknown. We know that MO and OQ are related by a ratio of 8 to 5. So it can be 8 to 5. It could be like 32 to 20. It could be 64 to 40. As long as the ratio, or whatever your lengths of your sides are, reduces to an 8 or a 5, it doesn't matter what the actual numbers are to solve the question. Therefore, to solve for PO, we're going to complete the proportion. I'm also going to set up first the other half, which is, we also still have an 8 to 5 ratio of MO to OQ. Let's use that to solve for the other missing side. So MN and the other corresponding side to MN is QP, 5.1. And you can solve for your missing lengths. PO is going to equal 8.375, and MN is going to equal 8.16. To finish the question, you need to do the B part. It says find the total area of two triangles. Total area. Area is equal to the base times the height divided by 2. The base of 13.4 times the height, MN of 8.16. Multiply those together, divide by 2, and add to that. Other side, the base would be PO, 8.375, times that by its height, 5.1, and divide that by 2. And we'll add them together. You add them together, you're going to get 76.028. When you do the rounding, the nearest whole, you're going to get 76. square meters for the total area of the two triangles. So you apply a proportion question, and at the end we're asked to do something a little bit different, which was to find an area. Next question. Angle S is equal to angle W. We'll put some marks in there to show they're equal. Angle T is equal to angle V. We'll mark those as equal. Oh, look at that. We now have enough information to prove these triangles are equal because we have two equal sides. Therefore, this angle and that angle must be equal because if two angles are equal, the third's equal. Now we have similar triangles. We have triangle STU must be similar to triangle from the dot to the check mark to the middle. So from the dot would be WVU. Find the length of UV. Hint, let UV equal X. And TU equals 13.8. TU up here seems to have a typo. That should say 13.8 minus X. I wonder if anybody will catch that from doing the practice. I'm guessing no. However, we'll pretend like we all love math. So ST over WV would equal TU over VU. ST is 3.1. WV is 5.7. They're proportional. Now, we want to solve for one side, and we know the whole length is 13.8, and one portion we don't know. We're going to call that X. So that's on the bottom, because it's from the triangle on the right. The triangle on the top is whatever X was. So if you look at this whole line, let's look at this question carefully. The whole line is 13.8, and this length is X. Then the other missing length, we'll do it in red, must be 13.8 minus X. So we're coming back to having an algebra question in the middle of a similar triangle question, but they're still doable. So we're going to cross multiply. When we do, we're going to get equations. So watch how I get beyond this step. 3.1 times X is 3.1X. 5.7 times 13.8 minus X needs to be written in a bracket so that we can solve it. Now, the next step, if we had more room, would be to clear the bracket. So 3.1x on the left is going to equal, going to multiply 5.7 by both terms, 78.66 minus 5.7x. Now you know x's have to go on one side, numbers on the other. If I bring the 5.7 to the left, I'm going to have 3.1x plus 5.7x will equal 78.66. Now, gather your like terms. 3.1 plus 5.7 is going to give you 8.8x, and 8.8x has got to be broken down to solve for x. You're going to have to divide both sides by 8.8 to clear your numbers. And the next line is going to read the quotient of 7.8 or 78.66 divided by 8.8. X equals your 8.9 when you round to the tenths place. 8.9 centimeters. And that's the value of UV, because UV is what we called X. That question was a little tricky. I hope that you followed along. Maybe play her back and watch it again. Question 7. Two triangles are similar. So if that's the case, let's draw two triangles that are similar. Try to draw them better than mine. It should be the same shape. To show them the same shape, I'm going to mark them the same shape so nobody can yell at me. I'm going to put a dot, and I'm going to put equal marks. Now those triangles are the same shape no matter what they look like. The lengths of the largest sides of the triangles are 26 and 33 respectively. The lengths of the largest sides. The shortest side in the smaller triangle is 18. Find the nearest meter, the length of the shortest side in the larger triangle. The largest sides of my triangles are the bottoms. So 26 would go in the smaller one, and 33 in the bigger one. The shortest sides are on the left. The shortest side in the smaller triangle is 18. Find the nearest meter, the length of the shortest side in the larger. So let's call this side X. So to solve for X, you would have to set them up so that they are corresponding. Say you would do 18 over X would equal 26 over 33. And to solve this, you're going to cross multiply 18 by 33 and then divide by 26. So X is going to be bigger than 18, obviously. Not a whole lot bigger. Do the math, you're going to get 22.846. Round the nearest meter. Going to get an answer of 23. That question required a little bit of thinking, but it wasn't particularly too bad. A hydro pole casts a shadow at the same time that a flagpole casts a shadow. So the hydro pole is 9 meters high, casts a shadow 2.8 meters long. Hydro pole, shadow. Flagpole casts a longer shadow. So if it's a longer shadow, one would presume a taller object. The assumption is that the angle of the sun is always the same. So therefore, you can get a similar triangle scenario. And you always assume as well that the poles and the flagpoles are perpendicular to the ground. Now you have similar triangles. A 9-meter high pole casts a shadow. Shadows are always in the ground, they're not in the air. 2.8 meters long. Flagpole casts a shadow 5.5 meters long. Find the height of the flagpole. So you would say 9 over X would equal 2.8 over 5.5. And that would give you enough setup to solve the math. X would equal the nearest tenths, 17.7 meters for the height of the flagpole. And the last question. Which triangles, if any, are similar and why? So, first step, you might want to try to decide which sides you think should correspond. So when you look at these triangles, if you can orient them, maybe take this one in your head and rotate it clockwise. Take this one, maybe flip it upside down to try and figure out which side is proportional to which side. To do the math, if they have the same ratio, when they reduce, they would be proportional. The longest side, 7.2, the longest side, 4.8, and the longest side is 6. Right? This is the longest. The angle for BC, or the BC, the second longest, 5.4. The second longest would be 3.6. And the second longest, 4.5. And the shortest would be your 3.6, your 2.4, and your 3.2. See if these triangles are going to be corresponding. You could take the longest side in the left, 7.2, and compare that to the longest in the middle, 4.8. Does that equal, the question mark, is it true that the medium side in this second one, 5.4 to 3.6, you get out your calculator and you cross multiply and see if the diagonals are true. If the diagonals are true, then you're potentially going to have similar triangles. You want to double check that, maybe by doing 7.2, 4.8, double confirm the shortest, 3.6, 2.4. The diagonals for the second setup are both equal to 17.28 when you multiply. The diagonals for the first setup are both equal to 25.92. That tells you, because the sides are proportional, this triangle and this triangle are indeed similar. If you go through and do the same thing, comparing, say, DEF and GHI or GHJ, they don't produce equal diagonals. Therefore, these triangles are not similar, but the first two are. Triangle ABC is similar to triangle DEF because this time we took our ratios and proved that they were corresponding. Therefore, we proved that the angles are equal. Instead of going from similar triangles to using that to find missing lengths, we took given lengths, proved they were proportional, and worked backwards to say that the two triangles on the left and middle, that those are indeed similar. So therefore, you could go further and say that angle B and angle F are equal, angle A and angle D were equal, and angle C and angle E are equal. Enjoy!